if you do under fractions, I call this, and most of the mathematical world calls this cross-canceling. The book calls this canceling or reducing before you multiply. Which is really what it is, but it's too long to say that 8,000 times a year. Reducing before you multiply. And here is what the gist of this. Write down this example problem. Many of you will leave this class in a much better mood than you started because 1 1/2 times 2 2/3. And as Drew can tell you, if I'm actually going to multiply this, Drew, the first thing I have to do is
make them in proper fractions.
correct. When you multiply fractions, you need to make them fractions. You can't just multiply the 1 times the 2 and that times that. Making this an improper fraction, you get 3/2, correct? 1 times 2 times 1 plus 1. And 2 times 3 is 6 plus 2 is 8/3. Okay? And then to do that, from here up until this point, we've done this. You multiply across, and you end up with 24 over 6. And 24 divided by 6 is 4. 4 over 1 or 4. Now, that's the normal way to do it, but you are going to want to take a little deductive leap and change into what we call do some cross-canceling because and it's not as much for this problem, but later on problems will get much more complicated and you're going to want to do that. And what cross-canceling is this. Let's go back to this where I had these two fractions times themselves. If you have 3/2 times 8/3, what you can do is, see it's kind of goofy for us to multiply and then when I get my answer from multiplying, then I just go and kind of do the reverse and then divide, because I divided both of these by that. You can actually reduce this before you multiply. What you're looking for is common factors that the top and the top ones have with bottom ones. For example, if I have, remember that whole thing where we had 3 times 3 times 5 over 3 times 5, and you could cross off that sort of stuff? This is the same thing. Okay, if you have a 3 on top and a 3 on the bottom, okay, you can cross that off and say, okay, 3 goes into 3 once and 3 goes into that 3 once. Okay, if I had 8 and a 2, and I can cross cancel these, what would I end up with? If you had 8 over 2 as a fraction, what would that reduce down to? Well, 2 goes into both of them, so you'd end up with a 1 and a 4. Well, that's what you're doing here. 2 goes into both of them, so it's a 1 and a 4. And then look what you're left with. You're left with 1 times 4 over 1 times 1, which is just simply a 4. It will make, because sometimes you'll end up with fractions and things that look like this. Let me show you something where it really makes a difference here. You know, if you have 3/5 times 10 over 12 times I don't know, 16 over 25. I don't know about you, but the whole thing of multiplying 3 times 10 times 16 and getting 480 over there, and then multiplying the bottom, 12 times 5 is what? 300 times 5 is 1,500, and then you've got whatever it is over 500, and then having to reduce it. It leaves yourself open to a lot of like calculating mistakes. But if you look at this and you say to yourself, well, can I reduce before I multiply? Can I cross cancel? I like to call it that. If you look at this, what could be cross canceled? What on top could be reduced by something on the bottom? Elijah?
3 to 12.
Okay, and you just say it like this. Well, 3 goes into 3 once, 3 goes into 12 4 times. And you can use this 4 to cross cancel it does. Drew, you can do what?
5.
With what?
With the 10.
10. You can't do bottoms with bottoms, but bottoms with top. 5 goes into 5 once, 5 goes into 10 twice. Anything else? Elijah?
The 4 and the 16.
4 goes into 4 once, 4 goes into 16 4 times. Anything else? Nope. You can't do the 2 and the 4 because they're both on top. And then you multiply it out, you get 8/25, and that is your answer, rather than doing, 1,500 under or whatever it was on top, what we have, 480 or whatever it is, 8/25. It will save you a ton of time, and it's much easier to do if you cross cancel. Does that sound like anybody have any questions on that? Let me give you one to do here. So if you have 3/4 times 4/5, 3/4 times 4/5. Okay, and rather than multiplying that over, what are you going to do? You are just going to, you see a 4 and a 4 there, they both cross off to give you a 1. And your answer is going to be 3/5. Nothing else cross cancels there. Did I say I was going to give you one? How about this one? 3 1/3 times 2 1/4. 3 1/3 times 2 1/4. Do that problem for 2 minutes. Oh, it's an exciting day. Record playing. Riley Harrington says,
Better than 1/2.
I don't know, let's check. This you change to 10/3, right? This changed to 9/4. What cross cancels? Well, 3 goes into both of these numbers, so 3 goes into 3 once, 3 goes into 9 3 times. What number goes into 10 and 4? 2. You divide them both by 2, you end up with a 5 and a 2. So you end up 5 times that is 15. 2 times 1 is 2, yeah. 7 1/2 is what I would get. Otherwise, you end up with like 90/27. Stop me there if you don't quite understand, get whatever, Jill?
Like, could you say 9 goes into 3 times?
No, 3 goes into 9.
Or 2 goes, which one would you, which one would you make 3?
You say that. You say that 3 goes into 3 once, 3 goes into 9 3 times. Whatever one you do. You divide these both by 3. What do you get if you divide this by 3? That's what you put next to the 3. What do you get if you divide this by 3? That's what you get. That's where they go.